Okay, everyone, I think we'll start the meet.
Okay, everyone, I think we'll start.
So, is my screen visible? Can anyone confirm with it? Okay. So, as we discussed about linear regression yesterday, so today we are going to discuss about logistic regression, their types, and also about SVMs. So, coming to logistic regression, before going into it, we will first know what binary classification is. So, binary classification is when we have to predict one of two possible outcomes. For example, predicting if an email is spam or not, or if a student will pass or fail, etc. So, now let's recap linear regression once again. So, as we know, it is where we predict continuous outcome based on one or more predicators. So, for example, if we want to predict someone's height based on their age, we might use a linear regression model, right? So now let's think about linear regression to predict a binary outcome. So like whether a student will pass or fail a test. So here y can be only 0 or 1, right? So but here is a problem. Linear regression can predict values anywhere from negative to infinity to like negative to positive infinity. So this doesn't work for us because probabilities must be between 0 and 1, right? So we can't have a probability of something like -3, -2, 1.5 and all. So that is why instead of linear regression, we use logistic here. So this transforms output of a linear equation into probability using a special function called sigmoid. So this squashes any input between 0 and 1, which exactly what we need for probabilities. So hence we don't use linear regression here for binary classification because it can predict values outside 0, 1 range. And the sigmoid function in logistic creates a shaped curve so which matches with probability. So now coming to types of logistic regression, there are basically two types that is binomial and multinomial. So firstly, coming to binomial, so it is a statistical method used. It is used when the outcome variable is binary. That it means it can have only two possible outcomes like 0 or 1, yes or no, or success or failure. So this type of logistic regression helps us predict the probability of an event when there are one or more predicators. So, for example, let's say we want to predict whether a student passes or fails based on the number of hours they study. So here the response variable has only two values, right? So making it perfect candidate for binomial logistic regression. So here coming to the implementation part. So this is an example of breast cancer dataset. This is commonly used for binary classification tasks. Coming to the first four lines of the code, here first one is these four actually we use for importing necessary libraries. So for first load breast cancer library, this helps us to load the breast cancer dataset. So for second one, the logistic regression library helps us to create a logistic regression model. So here in the third library, this is used to split the dataset into training and testing parts. And the last library is used to calculate the accuracy of a model. And so this line of code it actually loads the breast cancer dataset into X features and Y labels. And then this line of code is used to split the training and testing parts, where basically 80% of data will be used for training and 20% for testing. And this random state parameter basically ensures reproducibility of the split. So coming to these two lines of code, now we initialize the logistic regression here by using CLF, and we train the data. We train the data here, and then the trained data will be stored in the Y predicate. And at last, we finally calculate the accuracy of the model by comparing the actual labels to predicated labels in basically the testing data. So then we print the percentage of accuracy. We basically get around 95.61. So now coming to, are everyone understanding it? Okay. So now coming to multinomial logistic regression. So it is an extension of binary logistic because it allows prediction of outcomes with more than two categories. As we have seen in binary logistic, like it allows only two features, like either yes or no, success or failure, etc. But in multinomial, we can use more than two categories. So it is used when the outcome variable can take on multiple values, not just two. So let's say we want to predict the weather, and we have three possible categories here, like sunny, rainy, or windy. So this is a multi-class classification problem, right? So because we have more than two categories here to predict, so to apply multinomial logistic here, we break them into three separate binary classification problems. Like first one is it sunny or not? And the second, is it rainy or not? And then is it windy or not? So we then run each of these binary classifications independently based on input data. So for each category, we predict the probability of it occurring using logistic regression. So now coming to finding the solution, and once we have these predicted probabilities for each category, so we choose the category with the highest probability as the solution. So in the other words, if the probability of sunny is the highest compared to rainy and windy, so we can predict that the weather is sunny. Since the accuracy of sunny weather being sunny is more. So now coming to implementation of multinomial logistic regression, same like we first import necessary libraries. This is for we'll first split the data set into training and testing sets. We'll load the DCID data set. We'll create a logistic regression model, and this metrics is used to evaluate the model's performance. And then this line of code, it loads the DCID dataset as I told. And here we define the feature matrix X and response vector Y. So X contains feature values and Y contains labels basically. So then here again, this is used to split the training and testing sets. And here we basically use 60% of data for training and 40% for testing. And again here, we'll create a logistic regression model for multinomial and then use it for training. So here the trained data will be stored in this Y predicate, and then finally we'll calculate and print the accuracy of the model. That is, we'll get around 96.5. So I think this is for logistic regression. Its implementation types and all as we covered. So now KNN will be covered by Unnati. So Unnati, you can start.
Yeah, okay. I'll share my screen. Just a second. Is my screen visible? Okay. Hello everyone, now we are going to learn another interesting ML algorithm, KNN. KNN stands for K nearest neighbors, and as the name itself suggests, we are going to find K nearest neighbors in this. It is one of the most basic yet essential classification algorithms in ML, so let's dive deeper and understand this. So let's imagine that we have a scenario where we have two categories already present in our dataset, category A and category B. And now we added a new data point, so the question is, should it fall in category A or B? And that's where the KNN algorithm comes to assist us. At the end of performing this algorithm, we will be able to identify whether it belongs to category A or category B. So how did it do that? Step 1 is to choose the number k of the neighbors. You can choose the number k manually by testing different values of k and checking the accuracy, or you can also use hyperparameter tuning. Now calculate the Euclidean distance of k number of neighbors and get the k nearest neighbors according to the distance calculated. You can also use other distances such as Manhattan distance, but in most of the cases Euclidean distance is used, so we will stick to that. Next step is out of these neighbors, count the number of data points in each category. Give the new data point to the category that has maximum number of neighbors and your model is ready. So what is the formula for Euclidean distance? Can anyone tell me? Okay. It is the same which we have used in class 10 to find the distance between 2 points, root of x2 minus x1 whole square plus y2 minus y1 whole square. And this is the formula for Manhattan distance, mod of x1 minus x2 plus mod of y1 minus y2. Let's take an example where we have chosen k is equals to 3, which is our first step. Then next step is to find 3 nearest neighbors. As you can see, these data points are our 3 nearest neighbors. So 2 points lie in blue category and 1 in pink. Final step is to assign the data point to the category with maximum number of neighbors. So we will assign a new data point to the blue category. See, easy. That's how it, sorry. Let's take one more example, then we'll see the practical implementation of KNN. I have taken a small data set in which ingredients are categorized in different food types on the basis of sweetness and crunchiness. That's how it will look after plotting on the basis of features and categorized in different food types. Now we have a new ingredient, tomato. So tell me, to which category does it belong if its sweetness is given as 6 and crunchiness is 4? We are taking the value of k as 4. Here, tomato is categorized as a fruit, as most of her nearest neighbors belong to the category of fruits. As you can see, one belong to proteins, one belong to vegetables, and two belong to fruits. Let's see some pros and cons of KNN. KNN is easy to understand and implement, making it a good starting point for beginners in machine learning. As you have seen, it's a very easy algorithm. KNN is a non-parametric algorithm, which means it can handle any type of data. As new training data is added, KNN can adapt to it easily without the need to rebuild the model, which means it stores the entire training dataset and uses it directly to make predictions. There is no explicit training phase where a model is built. Despite being computationally intensive due to the need to calculate distances to all training samples, KNN can still be effective with large datasets. Let's see some cons of KNN. Classifying a new data point requires calculating its distance to every existing data point, which can be slow and computationally expensive for large datasets. And as I told you in adaptability part, it stores the entire training dataset, so which can be memory intensive for large datasets. Outliers in the data can significantly affect the classification results because KNN relies on the majority class in the k nearest neighbors. The value of k needs to be determined, which can impact the algorithm's performance. In dataset where classes are imbalanced, KNN tends to favor the majority class, leading to biased results. Does anyone have any doubt till now? Okay, now we'll see the practical implementation of KNN. So first we'll import all the required libraries, NumPy, Pandas, Matplotlib, and Seaborn. So you have already studied NumPy and Pandas. Now Matplotlib and Seaborn are used for data visualization. Then we'll import our dataset, titanic.csv, using the pandas function read_csv. And you can see the dataset using df.head. So here we have different features: sex, age, sib_sp, parse, fair, embarked, class, who, alone, and survived. Now we'll pre-process our data. So first we'll remove the unwanted features of our dataset, like who, which contains the same data as the sex feature, and alone, because it doesn't matter whether the passenger is alone or with his family. So we'll drop this columns, and here x is equals to 1 represents columns. In pandas, if you are using x is equals to 0, it represents row, and x is equals to 1 represents column. Now next is df.info. df.info and df.describe are used to describe various features of the dataset for getting a summary of the data frame. So df.info gives us the number of non-null objects in the dataset, and df.describe generates descriptive statistics for the data frame of the numeric columns. Now we are going to see what all columns do we have with us. So see, now who and alone columns are not here. And shape of the dataset. Then we'll check for the missing values. So 19.8% of the data is missing with respect to age feature. So simply dropping these feature will give us a loss of data. So we'll be using here the mean, median, or mode imputation for handling the missing values. So imputation should be done over the training set and then propagated to the test set. This means that the mean and median to be used to fill missing values both in train and test set should be extracted from the train set only. And this is to avoid overfitting. Age is a continuous variable. First we'll check the distribution of age variable to find out if they are Gaussian or skewed. So we'll use this code snippet to check the distribution of age variable. So as you can see, it is skewed. So now we'll split our data and then we'll find the mean. We'll split the data using train test split. So this is the median of our age, and now we'll fill all the missing values of age using this value of median. And then we are going to check the number of null values in age. See, 0 in the training set as well as in the test set. Now, for the missing values of embark, which is a categorical feature, we are going to replace the missing values with mode. And now check the number of missing values. So it is 0. Then we have categorical encoding. So we'll do one-hot encoding for the categorical features and convert them into binary values, true or false. So after doing one-hot encoding, these are our categorical features. As you can see, this sex feature is converted to true or false, and same with other features. Now do not forget to apply feature scaling in algorithms that use distance or gradient descent. Without standardization, features with larger ranges might dominate the distance calculations, leading to biased results. So we applied feature scaling, and then we'll train our KNN model. So we are going to use grid search CV for hyperparameter tuning. It involves finding the best set of parameters that maximize the model's performance. Cross-validation score evaluates a score by cross-validation. K-neighbors classifier class is used to implement the k-nearest neighbors algorithm for classification task, and classification report function builds a text report showing the main classification metrics. So here we are creating an object of the KNN classifier with default parameters, which you can then train on your data and use for making predictions. And this dictionary defines the set of hyperparameters and their respective values that you want to test. So here we are going to test the values k is equals to 3, 5, 7 and 9. And the one which gives the best accuracy, we'll use that. So here we'll get our best hyperparameters as n neighbors is equals to 3, that is the value of k is 3, and weights is distance. So the best KNN model can now be used to make predictions on new data or to evaluate its performance on a test set. Okay, so these are our cross-validation scores for different values of k, and as you can see, the k is equals to 3 is the best score, and this is the mean cross-validation score. So we'll fit our training data to this model. And now we are getting an accuracy of 0.98, which is 98%. So the 98% of the predictions made by our model are correct. Now we'll predict test results. After predicting the test results, we have printed the classification report as given. And this is our confusion matrix. You can also visualize the confusion matrix using this particular code snippet. Here this dark blue and light blue blocks represent true positive and true negative values respectively. True positive is that the predicted value and the actual value both are positive. And true negative is that the predicted value and the actual value both are negative. Both of these represent the number of predictions that are correct. Then we have false positive and false negative. So false positive is that the predicted value is positive but is actually negative. False negative is that the predicted value is negative but is actually positive. These represent the number of wrong predictions, which we can see is quite less here. So number of wrong predictions are only 3, and the number of correct predictions are quite high. So that's all for the practical implementation of KNN. Now you are free to ask your doubts. So you can ask your doubts now. Any doubts? Okay, thank you. Now, Charishma, you can continue.
Okay, yeah, so we'll start SVMs. I'll just share my screen. So here we are going to discuss SVM in machine learning algorithms. Also different types of SVM algorithms, and we'll also see how it works. So let's start what SVM is. It is the most popular supervised machine learning algorithm, which are used to solve the classification as well as regression kind of problems. So here we need to understand what is supervised. As you already know, yes, sorry for the noise. Okay. So as you know, what supervised is, it means we give the label data as an input, and coming to classification, it is where the target contains discrete number of possibilities. So for example, if you want to solve a problem where we want to classify either mail is spam or not, and we have two possibilities here. Such kind of problems are called classification problems. But if the target label contains continuous values, such kind of problems are known as regression. For example, let us say that we want to know the increase in salary of an employee based on his performance. So in this case, the increase in salary is continuous, right? Such kind of problems are known as regression problems. Support vector machine algorithms are used to solve classification kind of problems in ML. The goal of these algorithms is to draw a baseline decision boundary line to segregate the given data set into multiple number of classes. So here now this particular decision boundary is called as hyperplane. So in terms of SVM algorithm. So now the question comes in front of us, like how to draw this particular hyperplane in a given data set. So in this diagram, you can see. So there are we have two classes here. One is drawn in blue color and another one is green color. So now this particular data is linearly separable. We can draw a straight line like this. So, and also the other term is you can see, so basically for this red line, you can see this green dot and this blue dot are nearest points. So we can say that these two are the support vectors for this line. And also for this green line, uh, we can say that this green dot and this this blue dot are nearest points. So we can say these two are the support vectors for this green line. So and also another point is here we have only two features, so we are able to draw the line. But if we have more than two features, like 3, 4 and more, we cannot draw a straight line here. We need to use a plane, like as we have seen yesterday in multiple linear regression. So now coming to types of types of SVM. So there are two types of SVMs. One is linear and other is non-linear. In linear SVM, we can separate the data using a straight line. But in non-linear SVM, we can't correctly divide it. We need to use some mapping functions there. So we'll discuss them. So now coming to linear regression. So we'll understand it with this example. So you can see here that there are two features. One is represented by star symbols and other is represented by circles. So now you need to draw a plane. So basically we can draw multiple hyperplanes here, but we need to find out which hyperplane to use. So for this what we do is, as I told before about support vectors, so for this line this star and this dot are the nearest point data points. So we draw parallel lines to be over these data points as you see here. And also for this D hyperplane, you find out nearest support vectors, and as same like it, you draw parallel lines to D over these data points. So now you calculate this margin distance as you see the arrows here. You calculate distance like G2 and G1, and you will find out which is more. So basically by observing we can tell here G2 is less distance, and also here we can say G1 has more margin distance. So what we can say here is we can come to a conclusion that B is the hyperplane that we need, as most of the data points are correctly separated and also they are in a margin distance as we need. So now coming to mathematical representation of linear SVM. So you can see here this line is represented by this equation, and these data points where we drew a parallel line over them, This is -1, and this side data points has value of 1. So if we go beyond this -1 or beyond this one, here this side, if we go beyond -1, these values will be decreased, and if we come onto other side, will the values will gradually increase. So here we have seen both the distances are 1. So we'll basically, to know which hyperplane is best to use, we'll use this max formula. So the value we get for W, we use as that. Uh, Normally, we'll take that as hyperplane. So this is the calculation when we use it mathematically. So now coming to nonlinear SVM. So as we know, in nonlinear SVM, we can't separate the like we can't draw a straight line separating the data points exactly. So here we basically, you can see in this picture, uh, these are not in a format. We can't draw a straight line here. So to separate this, we'll basically use a mapping function as I told. So here I used z equal to x square plus y square, and when I used it here, basically we have two dimensions in this previous picture, that is x and y. But when we use that mapping function here, we are able to separate the data here. Like green dots come and sit near the x-axis, and these blue dots get separated from it. So, and also there will be another dimension. Third dimension will be created here when we use that mapping function. That is z. So now, same like we have done in linear SVM, we do the same process and then draw a hyperplane. We'll calculate the nearest points distance. We'll draw parallel lines over them, and then we can get a best hyperplane. So these are about SVM. I hope you understood. Any doubts? Did you understand it? So did everyone understand? Okay.
Okay, guys. Good afternoon. Myself Sriraj here. So, how many of you are seriously serious about the internship which we are be providing, like the internship referral and opportunity which we'll be providing at the end of the bootcamp? Just raise your hands if you are serious towards the internship referral. Only two. Okay. So basically, one suggestion I want to give you all people is that have you gone through the website of the company people? So let me share you. Charishma, once can you unshare the screen?
Yeah.
So basically, here are some of the tips which you wanted to keep it in your mind. So basically, this is a website of their company. So the company people were very much interested to create some AI based solutions like machine learning based predictions for they will be working on stock data. When you go as an intern for the company, you will be working there as a analyzing some stocks, like how you will be predicting some of the stocks like that. If your accuracy is more, they will implement the model in their company, and they will just a minute, and they will sell your model or the predictions which you are getting from your model. They will be giving that to the clients, and they will be charging something for that. How many GitHub account here? So okay, my voice is audible, right? Anyone respond once? Like, is my voice audible? Yeah. Okay. So basically, just go to this website called Kaggle. Here we will be providing some of the assignments. Those are all just for the base idea, just for you to get a base idea. If you want to explore more, just search Kaggle here and you will be redirected to this website. And here you can search. Like today, we have learned about the linear regression, logistic regression, KNNs, and SVMs, right? So if you want something like implementation of SVMs on stock data, you search it here. For some of the things you will be getting this thing, you will be getting like if you search implementation of SVMs, you will be getting some notebooks, some Jupyter notebooks where they have performed some codes on some particular data sets. You will be getting how to implement or those all things. uh, and after that, make sure you have created your GitHub repository. GitHub is an open source platform where you will be getting the codes and every stuff for different tasks, everything. So here also you can search. So basically, our company, the company which we are be going, will be working on the stock data, right? This week, you try to make yourself so that you can able to work on a stock data. So here you can search. Like today we have learned the KNNs, right? Like KNN implementation on stock data. See, here you can see. Already one person named Priya Rachel has worked on this particular task. Like she have used the KNN algorithm of machine learning and done some stock price prediction. Here you can open the repository and you can see the code here, like how she has done, like what is the summary, like readme file is nothing but what is the summary of a particular task. Here you can see the just a second. See, here you can see the code. You can just go through the code. If you are having any doubts, you can ask us also, or you can use ChatGPT to clear your doubts. Let me search for another things like SVM's implementation of stock data. Here you can see there are so many repositories containing stock data prediction, stock market prediction using SVMs. So you can search one of those things and you can get you search which are very easy to understand and what are very easy to understand and less code is there. Here you can see this repository I have got, Python ML SVMs. They have used it on Turkish quality stocks. Here you can see the .ipynb file, which is nothing but your Google Colab or your Jupyter Notebook file. You can see the things here, like what they are doing, how they are doing, everything you can see. And make sure you have your resume, a particular resume. We will be taking the sessions for the resume too, but make sure you have a basic resume and try to include some of the projects from data analysis and data science. We will be mentoring on your resume too after some days, like after the end of this boot camp. And another thing I want to mention is that how many of you heard about LinkedIn here? So make sure you have created a account on LinkedIn So that's it, guys. That's it for today. These are some of the suggestions I wanted to give to you. So what will we you doing after going, like after this session? What you will be doing, like after every session, once try to search in GitHub or Kaggle regarding. Today we have discussed the logistic regression, SVMs and KNNs, right? One search in Google or like Google or Kaggle or GitHub, and you will be getting some implementations of a particular algorithm on different data sets. Once go through and refer all of those things so that you will be getting a better idea on the algorithm which will be discussed here. And after that, tomorrow night we will be releasing a assignment on supervised learning. Once you done that supervised learning assignment also, you will be getting an overview like what is algorithms, like how to implement them on a particular data set, all those things. Is it clear, right? Any doubts? Feel free to ask if you are having any doubts. If you are not having any doubts, we can wrap up this session here.